Hello everyone, welcome to our final lunchtime webinar of the year in partnership with AURPO, where we've got not one but three presenters here to speak to us on the transport of radioactive material. As always, we'll go through the ground rules just before we start, so questions will all be asked at the end of the presentation, so ask them as we go through. There's a Q&A box at the side of your screen that you can click on. What you can also do is like other questions that are in there that other people have posted, and at the end, time permitting, we'll go through all of them, but we'll start with the most liked ones first. And any that aren't answered during the webinar time will be put on our website after we've finished. We've got the code that you can email to Tegan today to register your attendance, and you'll receive an email after the webinar so you can claim your CPD points for that. And as always, please send us your feedback. You'll get the link to the online survey after the webinar. I've always got to plug joining the SRP if you're not a member already. All our benefits are on there, so you get to keep up to date with the RP community, you get the newsletter every week, you get access to job vacancies, and you also get the chance to apply for professional status. So without further ado, to introduce our speakers, I'll hand over to Professor Pete Cole, who is SRP past president and current president of AURPO. Over to you, Pete.
Thanks, Sarah. I hope everybody can hear me. Good afternoon and welcome to this webinar. I'm delighted to welcome our speakers today, three of them, my colleagues and friends from the Office for Nuclear Regulation. I'd just like to say that my normal auto cue doesn't normally work with three people, so I'm going to have to read these introductions from a trusty piece of paper, so please forgive me. Paul Butler. Paul has been in the nuclear industry for the past 10 years. Prior to the ONR, he was a nuclear graduate with secondments in Magnox, Sellafield and Nuvia. Since 2014 at the ONR, his projects have included delicensing nuclear sites, direct shine assessment, and IRR 17 compliance. Currently, Paul is a nuclear safety inspector working with the Transport Competent Authority. Nicola Jaynes is a nuclear safety inspector with the ONR since 2017. She was lead inspector for land use planning within the Emergency Preparedness and Response Team. Now, since 2021, she's been the Radiation Protection Lead Inspector for Transport. Before ONR, Nicola was a Radiation Protection Manager at Urenco and Capenhurst. She is a member of the SRP's Non-Nuclear Industries Committee and a Fellow of SRP. Chris Jones has been a nuclear safety inspector at ONR since 2013, initially inspecting Defence Division and new builds. Now based in the Transport Competent Authority, covering a variety of topics, including packaging approvals, inspections and international work. He's the UK's rep on the IAEA Transport Safety Standards Committee, and before ONR he was a qualification specialist in the defence industry, dealing with explosives, aircraft and weapon systems. So without further ado, I believe, Paul, you're going to be up first. I will hand over to these three fantastic people. Thank you, Paul.
Thank you very much, Pete, and welcome to this webinar on transport of radioactive material. My name is Paul Butler, and I will be providing the first part of this webinar. This webinar will cover an array of areas within transport, such as current legislation and guidance around transport of Class 7 goods, what duty holders have to consider before transportation of Class 7 goods, what are ONR's expectations to be included within a radiation risk assessment and emergency planning, and finally the role of the Radiation Protection Advisor and Dangerous Goods Safety Advisor. So let's start firstly with ONR and other regulators. The Office for Nuclear Regulation is the competent and enforcing authority for the civil transport of radioactive material by road, rail and inland waterway. Yes, you can transport Class 7 goods via a canal. O&R fulfills this role by undertaking transport compliance inspections of consigners, carriers and consignees. This involves hospitals, industrial sector, radiographers, as well as nuclear facilities. In addition, O&R assesses transport package designs as well as shipment approvals. O&R receives notifications of any transport incident that involves Class 7 material, as well as undertake investigations where required. If there is an incident, how to notify O&R is provided on the O&R website. O&R also attends a number of stakeholder meetings from a transport perspective, such as RAMTUC and Badge GP. O&R also acts for approval of transport packages for other competent authorities. O&R interacts with other regulators and agencies via a number of methods. Firstly, through what is called an agency agreement. Now, this is a legal document for the transfer of statutory responsibilities. This is made possible through Section 90 of the Energy Act, though this requires ministerial approval as well as signature by the O&R chair. An example of agency agreement is our joint work with the police with regards to roadside stops for vehicle compliance with ADR. There's also a memorandum of understanding whereby can share information and experience to ensure regulatory consistency. An example of this is our MOU with health and safety executives. Let's look on to the legislation and guidance aspects. So this slide here provides an overview of the main regulatory framework in relation to the transport of radioactive material. One that is not mentioned on this slide is ADN, which is in relation to the carriage of dangerous goods by inland waterway. But to O&R's knowledge, no Class 7 goods are transported this way. If you are aware of Class 7 goods being transported by the canal, please inform O&R. Let's look at the international regulatory framework. Let's start at the top with the IAEA General Safety Requirements Part 3. And this provides aspects for Pacific Safety Requirement number 6, which is the regulations for the safe transport of radioactive material. Now, there are a number of guidance documents which then provide further information with regards to SSR 6. The two of the most interesting aspects of that are the radiation protection programs for the transport of radioactive material and the management system for the safe transport of radioactive material. So we have the IAEA expectations, but how does this transpose into UK law? Well, the IAEA standards are integrated into what is called the Orange Book. Now, this covers all dangerous goods aspects, including Class 7. This is then split into specific modes of transport: land, sea, rail, and air. So the ADR, RID, IMDG code, and the ICAO. And then these aspects are then put into law, UK law, via the road and rail is via the Carriage of Dangerous Goods 2009. Sea is the Merchant Shipping, Dangerous Goods and Marine Pollutants Regulation 1997. And air is the Air Navigation Dangerous Goods Regulation 2002. Within UK law, under the Carriage of Dangerous Goods 2009 Regulation 5, this states that you must follow ADR and RID. Hyperlinks are available within the webinar document, webinar presentation. However, the Carriage of Dangerous Goods 2009 also goes further than ADR and RID in several aspects, such as radiation emergencies and notifiable events. This will be stressed later on in this webinar, as well as keeping a copy of the transport documents for a minimum of 3 months. Now, Part 3 of the Carriage of Dangerous 2009 also allows for certain specific Class 7 exemptions and exceptions in accordance with Regulation 11B. Any exemption or exception under 11 or 11A is set out in a document called Carriage of Dangerous Goods Approved Degradations, Transitional Provisions and Exceptions. Again, a hyperlink for this can be found in this webinar. An example of this is if you are transporting up to 500 smoke alarms with an activity of less than 40 kilobecquerels per smoke alarm, you are exempt from ADR and RID. There's also authorizations under Regulation 12 related to Class 7 are published by O&R, and classes of dangerous goods requirements are published via the Department for Transport. Now, when transporting any Class 7 good by road, rail or inland waterway, you must be in accordance with IRL 17. This is a relevant statutory provision of the Health and Safety at Work Act 1974. The requirements of IRL 17 are enforced by ONR through the Health and Safety Enforcing Authority Regulations 1998, as well as the Health and Safety Enforcing Authority for Railways and Other Guided Transport Systems Regulations 2006. If you are transporting material, this begins from when a package is being prepared, such as packaging and labelling. This then when it's being transported by a carrier, it goes all the way through till the material is unpacked at its final destination. If you are following IRL 17, then the requirements under IAEA SSR 6 and ADR/RID 1.7.2 have been met. Within this slide is a list of international and industry guidance, such as the IAEA guidance documents. Some of these we've already discussed, the International Standards or ISO, as well as the Transport Container Standardized Committee documentation. Again, this is not a non-exhaustive list. And here on this slide is a list of useful technical inspection guides or TIGs, technical assessment guides or tags, as well as other ONR transport guidance, which is available on the ONR website. Again, this is not a non-exhaustive list. I just want to note that in relation to transport or activities, we do have the 5 steps to transport emergency planning, which is available on the ONR transport guidance website. I will now pass you over to Christopher Jones to talk about duty holders.
Right, so I'm going to start this second part of the presentation with a short run through of duty holders and expectations on duty holders, and then I'll get on a little bit to aspects around actual carriage of dangerous goods themselves. So the majority of duties on duty holders, specifically what are called main participants, can vary quite considerably. The key duties are identified within ADR 1.4 for road or RID 1.4 for rail. The primary duty holders are the consignor, the carriers and the consignees. So for those of you who are not aware of the terminology, consignor is the sender, carrier is the organisation transporting the material, and consignees are the receiving duty holder. Now, as you would expect, because the consignor is the organisation putting the radioactive goods into the public domain via transport, the majority of duties fall upon the consignor. There are some areas where the consignor can rely on other duty holders having completed their task. So, for example, if a consignor wishes to send a package that has been packed by somebody else, then they can rely on the fact that that other person has provided them with suitable information to say that the package has been packed correctly. Similarly, the carrier can rely on the consignor giving them all the information that they need to be able to carry the package. We're not expecting carriers to open a package up and check what's inside it. When it comes to radiation protection advisors and dangerous goods safety advisors, they aren't classically identified as duty holders within the regulations, although that doesn't mean that they don't have activities that they must carry out and activities that rely on those individuals being suitably qualified and experienced and giving the correct advice. The key for us within ONR with regards to duty holders, especially when we're doing compliance inspections, is that it should be very clear as to who is which duty holder. So whoever we are inspecting should be able to identify what duties they are carrying out, what responsibilities they are taking on board, and how they interface with all the other duty holders within the transport chain. Some of these duties will require duty holders to step outside of carriage dangerous goods regulations, either into ADR and RID or into IRR 17 or potentially other areas of law. So one of probably one of the most hotly debated definitions in our area of regulation is, what does transport mean? So let's start high up in the regulatory framework with the Carriage Dangerous Goods Regulations 2009 and Regulation 5. Now this starts with the definition that no person is to carry dangerous goods or cause or permit dangerous goods to be carried. In this set of regulations, the term carriage is referenceable to the term transport, and the reason that they're sort of slightly interchangeable is because by the time you work your way through the system, different sets of regs use different words for the same thing. They also use different definitions for the same thing, just to confuse everybody. So firstly, we'll jump off to ADR and RID, because that's what CDG Reg 5 directs us to. ADR and RID take the definition directly from SSR 6 at the IAEA level, and the definition of carriage within ADR and RID is the same as the definition for transport within SSR 6. And this is quite a wide-ranging definition. As you can see here, it says all operations and conditions associated with and involved in the movement of radioactive material. So this starts all the way back with somebody wanting to think about designing a new package to put material in, all the way through to receipt at the far end by a consignee of a package that's been sent to them, and everything in between. There's a slight difference when you step to IRR 17, because the definition of transport under IRR 17 starts at the point that a vehicle is loaded up and finishes when that load is removed from it. When we go to the enforcing regulations, which are the ones that tell us as regulators how we are what we are allowed to enforce against, transport defines with packing and continues through until the material has been unloaded at the far end. So in general, O&R will start looking at transport activities all the way back at the design phase of new packages. We will consider everything from the point of selection of a correct package, identification of the material that will go into that package, the physical packing of that material, the loading of that material onto the vehicle, the physical act of driving the material from A to B, and key here is including any in-transit storage locations. I'll come back to that in a second. And it finishes with the unloading of the package from the vehicle and it's being receipted by the consignee. Again, there is a difference there because the unloading could be carried out by the carrier, taking it out of the back of the vehicle, but until it has been receipted by the consignee at the far end, it is still in transport. In-transit storage is an interesting sort of term. It has a definition, and the definition is that the storage is only being carried out to allow the package or the material to change between transport operators or vehicles. So you can't just put it into a store and say it's still in transport if you don't intend to transport it onwards. Similarly, if you unpack the package, it stops being in transit storage. And there is a general time limit, which we have agreement with the Environment Agency. I think currently it's 14 days. If you exceed that amount of time, it stops being in transit storage and starts having to come under the Environment Agency's permitting regulations. So the key point of this is transport can be or is quite a significantly wider remit than a lot of people consider when they think of transport classically. Okay, let's have a quick look at some of the things to consider before you're transporting. There are a lot. Okay, let's not beat around the bush here. ADR, RID, Carriage Dangerous Goods Regs 2009, IRR 17, all put a whole series of requirements on different duty holders, different activities, different requirements to follow. Okay, we have appointment of suitably qualified and experienced safety advisors. I believe that's going to be looked at a little bit later. We have the requirement for radiation protection programs, and everyone has to do a radiation risk assessment, although it is obviously proportionate to the moves that's being carried out. So we're not expecting a war and peace for moving a couple of accepted packages around, but similarly, we're not expecting one side of A4 written on the back of a menu from a restaurant when we're coming to moving type B packages around. Emergency and contingency arrangements. This is quite a complex area, and it's going to be looked at a little bit later in this webinar, I believe. So I'm not going to go into detail on that one. The key aspect here on this next point is compliant and appropriately maintained packages. One of the key requirements for a consignor is to ensure that the package that they choose to use is appropriate for the material that they are moving. So it needs to be appropriate not just for the amount of radioactive material that is being moved, but it needs to be appropriate for the physical form of the radioactive material. So liquids and solids may have different requirements. You have requirements for security. There are requirements within ADR 1.10, which cover both normal levels of security and what are determined as high consequence radioactive material. They vary. If you are dealing with fissile components, so generally uranium, plutonium, americium, neptunium, or anything that has been irradiated within a nuclear reactor, you will most likely come under the nuclear industry security regulations for security. They are significantly more onerous for moving around those fissile materials. So be very, very careful when you're entering into that sort of realm that you're coming under the correct regime for security. NISA is still regulated by the Office for Nuclear Regulation, but it is actually carried out by our civil nuclear security and safeguards team, who we interface with on a regular basis. Transport documents. There's obviously a transport document that's required for every move. They can be quite prescriptive. So again, be quite careful, read the regulations correctly. There is a prescription on what it needs to go on and the order and form of that information needs to go on. Equipment and vehicles. Vehicles need to be suitable. They need to have correct tie down locations. They should have all the correct equipment on board. So we're talking fire extinguishers, warning signs, all those sorts of things. They must be marked and placarded correctly. Management system. This is a key paragraph within ADR. ADR 173 and the equivalent in RID. There is an expectation that anyone working within the transport of radioactive material will be able to demonstrate that they have a management system that can control and organize all of the activities they carry out. Everything from paperwork generation, through training, through management of individuals, vehicles, packages, material. All those aspects should be covered. In theory, an ISO 9001 is a good start. There is also a bit of guidance from the IAEA, but anything that is appropriate and of a suitable standard is acceptable. There are training requirements. They're dotted throughout ADR and obviously through IRR 17. Those training requirements can be quite specific to roles that people carry out, or they can be quite generic. So again, everyone involved with the transport of radioactive material will need some level of training. Quick look at some transport packagings. So just for information, packaging is the physical form of the box or thing that you're about to put material inside. Once you put material inside the packaging, it becomes a package. Yes, they do love to have terminology that sounds the same and means something different. So unpackaged, we don't tend to have very much of this in the UK. Sometimes we get little bits of it from the oil and gas and mining industries, and in some cases you will get it from decommissioning activities, but we don't get a vast amount of it around the UK. Exempt, there is no requirement. So if you're exempt, you do not fall under the carriage of dangerous goods regulations, but you may still fall under IRR 17 because it's still radioactive material potentially, even though it's not covered by CDG 09. You may also have other parts of legislation. Just going back to the basics of the Health and Safety at Work Act, there is still potential harm, and therefore it does have to be managed. Although, of course, the regulatory oversight of it will not be quite as in-depth. Accepted packages, these are for low levels of material. And what you can see there is there's quite a wide range, ranging from material within an instrument, material in its own right, special form, liquids, gases, and tritium gets its own special line within the system. So lots of these packages moving around. There are a lot of exemptions for accepted packages, but do be very careful when you use them because they have quite significant limits or quite well-defined limits. Industrial packages, this can be pretty much anything, 200-litre drums, ISO containers, in theory, a large plastic bag. They all will vary depending on the material that's being put inside them, the amount of material, and the requirements for each one. Moving up to the, let's say, slightly more well-controlled areas of packaging, you have your Type A package. Within a Type A package, you are allowed either an A1 or an A2's amount of material, so depending on whether it's special form or not. There are much more detailed requirements on the package design, its testing requirements, its labeling requirements, etc., etc. The key here is, up until this point, none of these packages have to have competent authority approval prior to being used. They are all self-approved by, officially, the consignor. So be very careful here. If you, as a consignor or one of your one of the organisations you work with is a consignor and is using a Type A or any of the previous packages, they have to demonstrate to us as the competent authority that these packages are fully compliant. Now that may be by getting information from the designer, but it may be that they have to generate some data and information themselves. Once you step on to the UF6 world, so uranium hexafluoride, big history of moving this material around. They are very well defined packages. They tend to come in large metal cylinders. They may have additional over packaging or outer packaging to manage fire and drop test requirements. But variation depending on enrichment and the form that the material's in are quite specific, and they have their own topic of area within SSR6 and ADR. Type Bs and Cs. Type Bs tend to be the biggest thing we see moving around in the UK. We've never had a Type C. Type C is for exceptionally large amounts of material, generally moving by air. Type Bs and UF6 packages all require competent authority approval. So does anything that is moving fissile material around. That competent authority approval will be in the form of an issuing of a certificate that generally has a 5-year time frame to it. Okay, a little bit about what consigners need to be able to do at the beginning. So obviously they need to demonstrate the package is correctly prepared. And as I noted, the consignor needs to be able to demonstrate the package is compliant for the activity it is being used for. There's the level of monitoring of dose rates and any contamination on packaging. And if you are reusing packaging, there needs to be a check to make sure it's been maintained. And we're looking at things here, not just physical structure of the package, but also seals, bolts, and anything to do with general wear and tear, as well as obviously drops and any damage that could be caused otherwise. You need to be able to demonstrate that you've maintained it and inspected those packages. So if you have reusable packages, there will be an expectation that during an inspection, someone might be asked to demonstrate that a package has been inspected on a regular basis. Now that may be every move, it may be on a weekly or monthly basis. That will depend on the package itself. Just because you are not using a package doesn't mean you can stop maintaining it, because it needs to be maintained for the point of time that you do want to use it. Packages need to be marked, labeled and placarded. You need a consignment document, and then you need to be able to consign it correctly. And that's not just throwing it at the guy who turns up at the door and says, I'm here to collect the package. It's correctly handing it over and doing that interface between the consignor and the carrier. Couple of little bits on vehicle placarding. Vehicles in the main have to carry radioactive placards on them. They go on both sides of the vehicle and the rear. If you're moving something large like an industrial package, an ISO container, these placards can go on the ISO container instead, but there are slightly different rules. So they have to go on all four sides, because at that point you could take the ISO container off the vehicle. Also note that if you are moving radioactive materials, apart from a couple of exceptions, so accepted packages, for example, they must have orange plates on the front and the rear of the vehicle. There are, as I said, there are a couple of exceptions, one being accepted packages. The second one being that you can use fireproof notices under one of the derogations, I believe road derogation number 9, that was already noted previously. One thing to note is that the orange plate has some very specific requirements with regards to being able to be fixed to the vehicle, remain fixed to the vehicle, and withstand a fuel fire for a, I believe, 15-minute period. There are orange plates being sold nowadays that have a nice little exclusion at the bottom of the website selling them that basically says does not meet the ADR requirements for an orange plate. A lot of these are magnetic. If you can't demonstrate your plate meets the requirements of ADR, then you are non-compliant. As noted before, a lot of these derogations have some very specific requirements. If you wish to use a fireproof notice, then the vehicle has to be under 3.5 ton. There have to be less than 10 packages on board with no fissile material, and the sum of the transport index cannot exceed 3. So thank you for listening to me. I'm now going to pass over to Nicola, who's going to take you through radiation risk assessments.
Okay, thanks Paul and Chris. So I'm Nicola Jaynes, as I said, the RP lead for ONR's Transport Competent Authority, and I'm going to talk to you about radiation risk assessments to start off with. So CDG requires duty holders to use their ionising radiation, IRR 17 radiation risk assessments to identify reasonably foreseeable accidents that are less than likely but reasonably possible, and to decide if a radiation emergency is possible. So everything starts from the radiation risk assessment, and if a radiation emergency is possible, then a CDG emergency plan is required to be produced. ONR has issued published transport radiation risk assessment guidance, and the link is on the slide. And RPAs should ensure that they work with their transport duty holders to produce radiation risk assessments for transport that meet IRR 17 and CDG requirements and ONR expectations. So what is, excuse me, a radiation emergency? Well, the definition from CDG is on the slide. ONR's Transport Radiation Risk Assessment Guidance is based upon this definition, and I've highlighted the key phrases there. So necessitates prompt action to mitigate serious consequences. We've based our guidance on that to reflect the fact that CDG uses those terms and refers to dose consequences to individuals rather than members of the public. So the guidance clarifies that we consider prompt action to include retrieval and decontamination until the radioactive material is contained in a safe location or able to be onwardly transported in accordance with CDG, and serious consequences to individuals to be doses greater than a millisievert. So if a CDG plan is needed, you don't need a separate IRR17 contingency plan, but you just should make sure that your CDG plan meets the requirements of IRR17, Reg 13 as well. And of course, the degree of planning should always be proportionate to the potential impact of any transport emergency. So common issues we face when we go to do transport compliance inspections. We come across people who are not meeting the requirement of IRR 17, ACOP paragraph 70 and 71 at all. So there is no radiation risk assessment, or there is one, but there are bits missing. And more often, more commonly, some people are unable to demonstrate how the requirements are met because they state that they've got multiple documents that constitute their radiation risk assessment, but it's not clear to pull out which documents meet which bits of paragraph 70 and 71. So in that instance, we tend to ask for a compliance matrix to be produced to demonstrate to us, the duty holder should demonstrate to us how they are compliant with those parts of IRR 17. We also see, and this is more common for non-nuclear duty holders, where they've got external radiation protection advisors, that generic templates are provided to the duty holder by the RPA with the requirement for them to add in their own individual bits so that the risk assessment is relevant to their transport practices. And what we tend to find in some instances is that the pro forma with insert duty holder's name is included in the management system of the duty holder, or just maintained in a file, not included in the management system, with all the individual pieces of information that's required to be inserted just left unaddressed. So obviously there's a lack of awareness for duty holders as to how they should be meeting the requirements of IRR 17. There's sometimes a lack of information about what's being transported, specifically what isotopes are being transported, the activities, the form, the package types used, and there's a focus on carriage. And Chris has talked about the carriage transport being wider than just physical carriage on a conveyance. So we sometimes see transport radiation risk assessment solely focusing on the movement on a vehicle, which is obviously not covering all the aspects of transport that are required to be addressed. There's sometimes no information on past doses, just statements saying doses are low, but there's no basis for that. And dose investigation levels are also sometimes included that are much higher than past doses. So some people will use the IRR 17 15 millisieverts dose as their default investigation level, rather than looking at a realistic investigation level, which will drive duty holders to make sure their doses to their employees are a LARP. And there's also examples of duty holders just not understanding or implementing their radiation risk assessments for transport properly. Other issues we face are package types not included in the radiation risk assessment, but there is a reliance on packages being robust and therefore emergencies not being reasonably foreseeable and not being assessed. There's sometimes no consideration of the impact of engineering and control measures or systems of work failing or not being implemented properly. So there's no assessment of what happens if particularly key systems of work aren't followed or maintenance of packages aren't carried out correctly. And we have seen in the past and continue to see that when assessing accident doses, people sometimes rely on generic documents that have assessed if there is a problem with the type A package and someone is at 1 metre away from that package, or if they're at a cordon that's 10 metres, 20 metres, 30 metres, this is the dose that individual would get, and that is cited as the dose for the potential accident. But they haven't looked at what's the dose that an individual has to get to go into that cordon, which might have more than one type of package there, or more than one of the same type of package there. So what dose would that individual get if they had to do some remedial action to sort of retrieve the package and get it into a safe state for onward transport? And finally, we often see no clear conclusions about whether doses can be above a millisievert in accident situations, and therefore no clear conclusions about radiation emergencies. Moving on then to emergency planning. ONR have published on our website the 5 steps to transport emergency planning guidance document, and the link is there. And I'm just going to take you through the 5 steps. So we've talked about this just now, but step 1 is to do your radiation risk assessment. So you're about to get involved in the transport of radioactive material. You need to perform a risk assessment before you do anything for the first time. And then obviously the Management of Health and Safety at Work regs requires the ongoing maintenance and review of that radiation risk assessment after you've started the transport. So you should do your radiation risk assessment, make the decision as to whether or not your accident dose consequences in the year following the accident can really realistically exceed a millisievert to any individual, and make sure that if it can, then you produce a CDG emergency plan. And the degree of planning should should be based on the potential impact of the radiation emergency, and also on the likelihood of the radiation emergency occurring, where that should also determine the level of planning. So if you've got a low likelihood, perhaps less planning, but a high likelihood, more planning. Even if no plan is needed, remember a contingency plan under IRR 17 may still be required if a radiation accident, a reasonably foreseeable accident is identified. So you will still need some sort of contingency plans. Step 2, you've done your radiation risk assessment, but we'll assume in this case that you've decided that you can have a greater than 1 millisievert dose to any individual in the year following the accident. Therefore, you are required to have a CDG emergency plan. So before carriage begins, you should make sure that you take into account Reg 8 of IRR 17, Reg 8.3, and you should make sure that you prevent accidents, that you limit the consequences of accidents, and that you provide employees with information, instruction and training and equipment to restrict their exposure. And the principles that you should consider when you're preparing your plan is to avoid physical injury to any person, to reduce or stop the radiation or contamination, to reduce the exposures to individuals and the environment, and to provide medical treatment, and then prioritise implementation of the plan in relation to dose rates and to contamination levels. Okay, so you've produced your plan. The next thing you need to do, step 3, is to rehearse it at suitable intervals, and CGG requires that to be not exceeding 3 years. And then you review your plan and you continue to test your plan to make sure that you can demonstrate that it is practically implementable, if that's a word, to bring about as a conclusion to the radiation emergency. So if you're a duty holder that relies on an external radiation protection advisor, for instance, to provide an emergency response to the scene of an accident, how far away are they from that accident? How practical is it to get them there within the right amount of time to give the advice that they need? And duty holders must prepare a report on the outcome of the tests that they do within 28 days of the test, and that report must be sent to us within a further 28 days after its preparation. Step 4 In the unfortunate event that you've had a radiation emergency, you're now into implementing the emergency plan, and there are certain duties of individuals who under CDG. So the driver has a duty to notify emergency services, the relevant local authority, and the consigner and the carrier. The carrier and consigner have duties to make a provisional assessment of the circumstances of the accident and consult with the emergency services, the health authority, and the relevant local authority. And additional to that, a consigner who consigns a package that's been in a radiation emergency must make sure that before that package is onwardly transported, it's examined and a certificate is issued either by the consigner or its agent that it still meets the requirements of CDG. And the final step, you've had your radiation emergency, you now need to look at what you do post the emergency. Now, the one thing that just slotted in here, it doesn't really fit, is that ONR has a duty to provide prior information to the public on radiation emergencies associated with transport. And the link to the guidance that we provided is on our website there, just for your information. But you've had your radiation emergency, you now need to report that radiation emergency. So you have to assess the emergency, complete a written assessment within 12 months, complete an assessment report within a further 28 days, and submit that report within a further 28 days from completing the report. So you've got 12 months and 56 days from a radiation emergency to get the report to ONR. And then there's an additional duty to provide a handover report to the authority responsible for recovery following the radiation emergency, and that's to be done as soon as reasonably practicable. And the recovery authorities are on the slide for England, Scotland, and Wales. So moving on, just to conclude and to finish with radiation protection advisors and dangerous goods safety advisors. Employers who work with ionising radiation will have a duty to consult with a suitable radiation protection advisor for advice on complying with IRR 17. And IRR 17 specifies what should be consulted upon, and that includes radiation risk assessments. So if an individual wishes to act as an RPA, they must either hold a valid certificate of competence from an organisation recognised by HSE as an assessing body for that competence, or hold a national or Scottish vocational qualification at level 4 in radiation protection that's been issued in the last 5 years. And if an organisation wishes to act as an RPA body, so not individual RPAs, but a body that has individuals that together constitute an RPA, then it must apply to HSE, to the Health and Safety Executive. And there's only one current assessing body for certification of individual RPAs, and there's a list of RPA certificate holders on its website, which is the RPA 2000 website. And a full list of RPA bodies can be found on the Health and Safety Executive's website, as well as additional information about radiation protection advisors. DGSAs, dangerous goods safety advisors, anyone involved in the transport of class 7 material by road or rail is required to appoint under ADR and RID one or more safety advisors to advise them on the transport of that material and to prevent the risks associated with that transport. And DGSAs are required to hold a vocational certificate, training certificate by the competent authority or by a body designated designated for that purpose by each contracting party. And the contracting party is the country that's a signatory to ADR and RID. And the DGSA must also have a certificate which they've received after passing an examination that's approved by the competent authority or of the contracting party. And the Scottish Qualifications Authority currently set DGSA examinations, which must be undertaken in every 5 years. Now, the Class 7 course is about to be recognised by ONR as relevant good practice for DGSA training, and we're just awaiting an official report from the Department for Transport for that. When to appoint a DGSA, we've issued guidance. Again, there's a theme here. We've issued a lot of guidance on our website for when to appoint a DGSA, and also how the DGSA should what the DGSA should consider when producing its annual report. But there are two possible scenarios in which ADR and RID may exempt you from appointing a DGSA. And these exemptions are implemented into GB law through CDG. But that means that if you're transporting internationally, they may not apply unless that country has also adopted those exemptions. There's detailed guidance, as I've said, which explains the basis for the exemptions. But in summary, if you're transporting anything other than accepted packages, then you need to appoint a DGSA. The other thing to highlight is that ADR 19, the amendment in for ADR 19 change the requirement for consignor only companies to appoint a DGSA. Previously, they were exempt. By the end of this year, if you're a consignor only company, then you will be required to appoint a DGSA unless one of the exemptions applies. And the video, the link to the video there will give you more information. It's a video that DFT have produced to explain this. DGSAs have to prepare an annual report. They have to advise duty holders on how to comply with regs, and they have to produce an annual report in relation to the activities that the duty holders have undertaken in that year. And this needs to be kept for 5 years and made available to the competent authority, to ONR on request. And again, we've produced guidance, as I've said before, on what the content of a DGSA report should be. And duty holders should act on the non-compliances raised within the DGSA annual report. We sometimes see, we get to do a transport compliance inspection. There's a really good DGSA report with actions that the duty holder should take that haven't been acted upon, that we then find if duty holders had acted on their safety advisor's advice, then they'd have had a far easier time during an ONR inspection. Okay, then, so just to sum up, so Paul has taken you through our why we were involved in the regulation of civil transport of Class 7 material and our relationship with other regulators. Excuse me, he's looked at legislation and guidance. Chris has took you through things that duty holders, the main duty holders, and things to consider as a duty holder before transporting. And I've taken you through radiation risk assessments, emergency planning requirements, and safety advisors. Thanks very much for your time, everybody. If there are any questions.